I am Sambaraj, Assistant Professor, Institute of Aeronautical Engineering College. Today we are going to discuss about a remainder concept, which belongs to number system or properties of numbers. A remainder concept. Remainder is always less than the divisor. Example, 27 divisible by 5. General method, 5 into 5, remainder 2. Here calculate only remainder but not quotient. This concept is called remainder concept. Condition, remainder is always less than the divisor. If it is divisible by 5, remainder should be less than 5. Only one condition. Next, sample examples. First example, find the remainder on dividing 21 into 22 into 23 into 24 into 27 by 5. Option A 1, B 2, C 3, D 4. General method. First you apply the operator 21 into 22 into 23 into 24 into 27. Calculate that solution. Is divisible by 5, remainder only answer. That method using calculator only possible. General method lengthy and complex method. Using shortcut method of remainder, that method easy method. Each number is divisible by 5. That means 21 divisible by 5. Consider only remainder but not quotient. 21 divisible by 5, remainder only 1. First calculate individual remainder but not quotient. Next 22 divisible by 5, remainder 2. Next 23 divisible by 5, remainder only 3. Next 24 divisible by 5, remainder 4. Next 27 divisible by 5, remainder 2. Remainder 2. Next to apply the operator, a 27 divisible by 5, remainder only 2. 25 by 27 by 5. 5 into 5, 25. Remaining means remainder only 2. Next to apply the operator multiplication, 1 into 2 into 3 into 4 into 2. Next 2 into 3 into 4 into 2. 48. This product is 48. We know that remainder always less than the divisor. Again divisible by 5. 48 divisible by 5. 5 into 8, remainder 3. So option C only correct. This is about remainder concept method. But we know that general procedure. Above problem, first you have to calculate the solution. Divisible by 5, remainder only correct. Suppose lengthy type of questions are given, using calculator too difficult, because I think campus placements and also competitive exams, calculator not allowed to the exam. Just you apply only shortcut method. The method, each number is divisible by 5 or divisible by some number. Next to apply the operator. But final solution is always less than the divisor. That is only correct. Suppose same example. Suppose 27 into 5. 27 into 5. 27 into 25. 21, 22, 23, 24, 27, 25. The last one 25 divisible by 5. That remainder is equal to 0. 25, that value exactly divisible by 5, remainder 0. Next to apply the operator, here 1 into 2 into 3 into 4 into 2 into 0. If 0 is multiplied by any number 0. Here again divisible by 5, 0 by 5, remainder 0. Here you check the problem. When 5 multiples that numbers are given, that question remainder always 0. 5 multiples not given, just to calculate this procedure. This is called a remainder concept. Remainder means remaining or remainder. But consider only remaining but not quotient. Okay? Right. Next. Second example. Find the remainder on dividing 49 whole cube into 74 whole square by 24. A4, B8, C10, D12. Here calculate only remainder but not quotient. Don't confuse. You read the problem but not unit digit. That's separated. Here unit digit and remainder, these two are separated. Don't mix the topics. Don't mix the logic. Here method, first calculate individual remainder. First 49 whole cube, 49 divisible by 24. Here 49 divisible by 24, remainder only 1, quotient to 2, remainder 1. Next to apply the operator cube, 1 cube only 1. Similarly, 74 divisible by 24. 74 means 24 into 3. 74 into 3, remainder only 2. Next to apply the operator 2 to the power of 2, only 4. First one 49 by 24 to 24 into 2, 48, 1. Apply the power. Next 49 whole cube, 74 whole square. When divisible by 24, remainders 1 and 4 respectively. Next to apply the operator 1 cube 1 into 2 square 4, 1 into 4 4. This is less than 24. Option A only correct. Remainder should be less than divisor. If it is more than 24, again divisible by 24. That number convert into less than 24. That is only answer of the given problem. Okay? Right. Second. Next, third example. Third example. A note, third example, note condition. Note, suppose here 8 to the power of 100 by 7. Find the remainder on dividing 8 to the power of 100 by 7. 8 to the power of 100 by 7. First calculate individual remainder. 7 by 8, remainder only 1. Next to apply the power 100, 1 to the power of 100, 1. Therefore, 8 by 7, 8 to the power of 100 by 7, remainder only 1. But third example, here 2 by 7, first calculate individual remainder, next to apply the operator, a 2 by 7, remainder only 2. Apply the power 100, 2 to the power of 100. If 2 to the power of 100 is more than 7, 2 to the power of 100, 2 into up to 100 times that value divisible by 7. That is the general procedure of a problem. Next to apply shortcut method. But 2 to the power of 100 directly not possible. Next to apply the shortcut method. A concept of the topic. 2 and 7 calculate remainder property and implement only cyclicity. This is a topic depending only cyclicity. By using repetitions calculate only remainder. That is the procedure of the topic. 2 to the power of 100 by 7. This is also written as a 2 to the power of 100 by 7. Next general property. 2 and 7 remainder property. First assumption 2 to the power of 1 by 7. 2 to the power of 1 by 7 is equal to 2 by 7. 2 is not divisible by 7. Remainder only 2. 2 by 7. Don't convert into decimal. 0.02. That is not correct. Consider only fraction. 2 is not divisible by 7. Remainder only 2. Similarly, 2 to the power of 2 by 7. 2 to the power of 2 by 7 means 4 by 7. 4 by 7, again 4 is not divisible by 7, remainder only 4 because not divisible. Next, similarly, 2 to the power of 3 by 7 is equal to 8 by 7. 8 by 7, 7 into 1, 7, remainder only 1, remainder only 1. Next, 2 to the power of 4 by 7 is equal to 16 by 7, 2 to the power of 4, 16. 16 by 7, remainder only 2, that is starting number. Stop here only. Next, 2 and 5, 2 and 7, remainder property, 2 for 1, 2 for 1, cyclic repeated. Just implement only cyclicity. 2 for 1, 2 for 1, cyclic repeated. 3 numbers are cyclic repeated, then power divisible by 3. Suppose 4 numbers are cyclic repeated, then power divisible by 4. 5 numbers are cyclic repeated, then power divisible by 5, and so on. Depending only cyclicity, number of repetitions only. Here 100 by 3, here 100 by 3, consider only remainder. Here 3 into 1, 3 into 33, remainder only 1. When remainder is equal to 1, answer is, when remainder 1, answer is first term of the repetition. When remainder 2, second term of the repetition. When remainder 0, answer is last term of the repetition. Your method is just implement only cyclicity, then power divisible that number only. Here 3 numbers are cyclic repeated, then power divisible by 3. Here 100 by 3, remainder 1. When remainder 1, first term of the repetition. When remainder 2, second term of the repetition. Remainder 3, third term of the repetition. Remainder 4, fourth term of the repetition, and so on. But remainder 1 means, therefore, first term of the repetition. First term of the repetition only 2. Therefore, 2 to the power of 100 by 7. First term of the repetition only 1. 1 means option A only correct. This is about remainder topic concept. This is the general procedure, short method. Next, also second method also applicable. This is the first method. Second method. Second method, a numerator convert into a near to denominator. Second method, that method also very easy. A numerator and denominator. Numerator convert into a near to denominator. A denominator 7. The numerator convert into 7 means near to 7. A 2 to the power of 3, 8. A 2 to the power of 3. A 2 to the power of 3, this answer 2 only correct, but not A. First term of the repetition only 2, B only correct. Here next, 2 to the power of 3, whole to the power of 33 into 2 to the power of 1. 2 to the power of 100 also written as 2 to the power of 3, whole to the power of 33 into 2 to the power of 1. In numerator, total number of 2's only 100. Next, denominator by 7. Next, 2 cube 8. 8 to the power of 33 into 2 to the power of 1 by 7. Next, individual 8 by 7. 8 by 7, remainder 1. 1 to the power of 33, 1 into 2 by 7, remainder 2. 2 to the power of 1. 1 into 2, 2. Therefore, answer B only correct. This is also correct method. Second method, first method. First method, cyclicity. Second method, numerator convert into a near to denominator. A 2 to the power of 100 also written as 8 to the power of 33 into 2 to the power of 1. But numerator and denominator, by using numerator and denominator, that value convert into a 1. Next, 1 to the power of any number is equal to 1. The 8 by 7, remainder 1. 1 to the power of 33, 1. Next, 2 to the power of 1 divisible by 7. Calculate individual remainder. 8 to the power of 33 divisible by 7. 2 to the power of 1 divisible by 7. Next, to apply the operator. 8 to the power of 33 by 7, remainder 1. 2 to the power of 1 divisible by 7, remainder 2. Apply the operator multiplication. 1 into 2, 2. Therefore, 2 to the power of 100 divided by 7, remainder only 2. Option B only correct. This is about a remainder concept procedure. Either first method or second method. Both are correct. Okay, right. Next, fourth one. Find the remainder on dividing 3 to the power of 197 by 5. A 9, B 3, C 7, D 1. Same method. First method cyclicity. Second method numerator convert into a near to denominator. Both methods correct. Okay. Here first one cyclicity. Here 3. This is also written as 3 to the power of 197 by 5. Next, by using assumptions. When power 1 to 3, so 3, 4 and so on. Your next method, here 3 to the power of 1 by 5. Here 3 to the power of 1, 3, 3 by 5. Remainder only 3. 3 not divisible by 5. Next, 3 to the power of 2 by 5 is equal to 9 by 5. 9 by 5, remainder only 4. Next, 3 to the power of 3 by 5 is equal to 27 by 5. Remainder only 2. Next, 3 to the power of 4, 81. 81 divisible by 5. Remainder only 1. Remainder only 1. Similarly, 3 to the power of 5 by 7. 3 to the power of 5 by 7. 3 to the power of 5, 243. Divisible by 5. Remainder only 3. Remainder only 3. Stop here. Here 3 means that is first term of the repetition. Here next to 3 and 5 remainder property. 4 numbers are cyclic repeated. 4 numbers are cyclic repeated. Then power divisible by 4. Here power 197. 197 divisible by 4. Here 197 divisible by 4. Remainder only. Here 197 divisible by 4. Remainder only 1. When remainder 1 means answer is first term of the repetition. When remainder 1 3, remainder 2 4, remainder 3 2, remainder 0 1. But remainder 1 answer is first term of the repetition. 3 to the power of 197 divisible by 5, remainder only 3. Option B only correct. This is about fourth example method. Here important assumptions only important. Using assumptions calculate number of repetitions. But here 3 and 5 but not unique. Previous example only 3 numbers only cyclic repeated is not equal to 3. Here 4 numbers are cyclic repeated. 2 numbers are cyclic repeated. N numbers are cyclic repeated. Then power divisible by n. That is the procedure of the topic. Here 4 numbers are only cyclic repeated. Then power divisible by 4. 197 divisible by 4. Consider only remainder. Remainder only 1. 197 divisible by 4. 196 exactly divisible by 4. But remaining part only 1. When remainder is equal to 1, answer is first term of the repetition. This is the first method. Suppose second method, second part. Here 3 to the 5 multiples. Here 3 convert into a 5 multiples, near to 5 multiples, that to convert into a 1. Then problem solution easy, because 1 to the power of any number is equal to 1. Here next second method. Here 3 to the power of 4, 3 to the power of 4, 81. 3 to the power of 4, 81. Here next whole to the power of, convert into whole to the power of, something 197, convert into 197. Here 197 means 4 to the power of, I think 196. 196 exactly divisible by 4. Here 4 into 1, 4 into 4 is 4 into 4, 16, 4 into 9, 40, 49. The 49 exactly divisible. A remaining part only 3. This is called 3 to the power of 1. Total 197, 197. Divisible by 5. Next, this part means 3 to the power of 1 power something. That value 3 to the power 4, 81. 81 by 5, remainder only 1. 1 to the power of any number is equal to 1. 3 power 1 divisible by 5, remainder only 3. Then 1 into 3 is equal to 3. This is the correct answer. Okay. This is total is equal to 49. 49. 3 to the power, sorry, 4 into 40. 3 to the power of 4 into 49. This is also written as a 3 to the power of 4 into 49. 4 into 49. 3 to the power of 4, 81. 81 divisible by 5. 5 into 16, 1. 1 to the power of 49, 1. Next, calculate 3 to the power of 1 divisible by 5. Remainder only 3. Next, to apply the operator 1 into 3, 3. That value less than 3. Then remainder should be less than divisor. Answer only 3. That method also correct. That is only one step answer. Yes, right. Using cyclicity, this is the method. Yes, fourth example answer is B only correct. Okay. Yeah, next fifth example. Find the remainder on dividing 47 all to the power of 100 by 9. A4, B5, C7, D9. 47 all to the power of 100 by 9. Here 47 all to the power of 100 by 9. First, 47 a general method. 47 all to the power of 1 by 9. 47 all to the power of 2 by 9. 47 all to the power of 3 by 9. That method lengthy and complex method. Because 47 whole square, 1 minute not sufficient. Your first target, numerator convert into a single digit. 47 divisible by 9, this value convert into a less than 9. Convert into a less than 9 or convert into a single digit number. In 47 by 9, 9 into 5, 9, 9 into 5, 45, remainder only 2. The 47 all to the power of 100 by 9 is also written as, 47 all to the power of 100 by 9 is also written as a 2 to the power of 100 by 9. This is the method. Both are same. Either you have to calculate this one or this one. But by using 47, that method lengthy and complex method. 47 whole cube, 47 whole 4, 47 whole to the power of 5. That value too lengthy. Using calci only possible, but not general. Your next method, that value convert into a single digit, that is less than 9. Single digit less than 9. Here 47 by 9, that value convert into less than 9. Here 47 means 9 into 5. 9 5 is a 45. Remainder only 2. That is also written as a 2 to the power of 100 by 9. Now check 2 and 5 remainder property. A 2 and 5 remainder property, same method. A 2 to the power of 1 by 9. A 2 to the power of 1 by 9 is equal to 2 by 9. A 2 by 9. 2 is not divisible by 9. Remainder only 2. Similarly, a 2 to the power of 2 by 9. A 2 to the power of 2 by 9 is equal to 4 by 9. Remainder 4 is not divisible by 9. Remainder only 4. Next, similarly, 2 to the power of 3 by 9 is equal to 8 by 9. 8 by 9 not equal to 1. 8 by 9, 8 not divisible by 9. Remainder only 8. Remainder only 8 but not 1. Next, 2 to the power of 4 by 9 is equal to 16 by 9. 9 into 1, 9 into 1, remaining only 7. The remainder only 7, 16 by 9. Next, 2 to the power of 5 by 9 is equal to 32 by 9. 9 into 3, remaining only 5. Next, 2 to the power of 6 by 9 is equal to 64 by 9. Remainder only 1. Similarly, 2 to the power of 7 by 9. 128 by 9, remainder only 2. Stop here only. This is called first term of the repetition. This model important. This example important to competitive exams. Here because here number of repetitions only 6 here. Lengthy example. Here once again, a 2 to the power of 1 by 9, remainder 2. 2 to the power of 2 by 9, remainder 4. 2 to the power of 3 by 9, remainder 8. 2 to the power of 4 by 9, 16 by 9, 7. 2 to the power of 5 by 9, 32 by 9, remainder only 5, consider only remainder but not quotient. A 2 to the power of 6 by 9 is 64 by 9, 9 into 7, 63, remainder only 1, 2 to the power of 7 by 9, 128 by 9, remainder only 2. A remainder 2 and 5 remainder property. Here 6 numbers are cyclic repeated. 6 numbers are cyclic repeated, then power divisible by 6. Here power, when power is 100, then 100 divisible by 6. Here 100 by 6, consider only remainder 100 by 6. Here 6 into 1, 6 into 16, 6 into 16, 96. Remainder only 4. When remainder 4, answer is fourth term of the repetition. Remainder 1, 2, remainder 2, 4, remainder 3, 8, remainder 4, 7, remainder 5, 5, remainder 0, 1. But 100 by 6, remainder only 4. When remainder 4, answer is fourth term of the repetition. Then answer is 7. Therefore, 47 all to the power of 100 by 7, remainder only 7. See only correct. This is only important problem in remainder concept. Important. Next, or second method. But second method, consider only 2 to the power of 100 by 9, but not 47 by 100 by 9. That method lengthy and complex method. A 2 to the power of 100. 2 to the power of 100 is also written as 2 to the power of 6. A 2 to the power of 6 all to the power of 19. A 2 to the power of 6 all to the power of 19. A 2 to the power of 6 now. 2 to the power of 6 means a 2 to the power of 6 means 2 to the power of 6 means 96. 2 to the power of 6 means 64. 64 divisible by 9, and a 2 convert into a multiples of 9. That is remainder only one case. A 2 to the power of 6, 64 by 9, 1. A remaining part only. A remaining number of 2's only 4. Numerator convert into a total number of 2's only 100. A 2 to the power of 6 all to the power of 16, 96. Remaining 2's only 4, that is 2 to the power of 4. A divisible by 9. This is also written as 64 all to the power of 16 into 16 by 9. Then calculate individual. 64 by 9, remainder only 1. 1 to the power of 16 only 1. Next 16 by 9, remainder only 7. Next to apply the operator, 1 into 7 only 7. Therefore answer is option C only correct. Here apply both methods, but both methods indicate same answer. Either apply general procedure or short procedure. But both answers are indicate only unique. That is only 7. This is about a fifth example solution, 2 and 9 property. Next example number 6. Example number 6. Equation model in remainder concept. Find the remainder on dividing 10 to the power of 1 plus 10 to the power of 2 plus 10 to the power of 3 and so on 10 to the power of 90 by 6. A0, B2, C4, D6. Method. First calculate individual remainder. Next to apply the operator. Finally, that answer should be less than 6. If it is more than 6, again divisible by 6, that result convert into less than 6. If it is less than 6, that option only correct. This is the concept of the topic. A method. A first one 10 to the power of 1 by 10 to the power of 1 divisible by 6. A 10 to the power of 1, 10, 10 by 6. 10 by 6 remainder only 4. 10 by 6 remainder only 4. 6 into 1, 6, remainder only 4. Similarly, 10 to the power of 2 by 6. 10 to the power of 2, 100. 100 by 6. 6 into 16, 96. Remainder only 4. Remainder only 4. Similarly, 10 to the power of 3 by 6 is equal to 1000 by 6. Again, remainder only 4 and so on. A 10 to the power of 90 by 6 also remainder only 4. A 10 and 6 remainder property. only one number only cyclic repeated, that is only 4. A 10 to the power of 1 by 6, 10 to the power of 2 by 6, 10 to the power of 3 by 6, 10 to the power of 4 by 6, and so on 10 to the power of n by 6. N is any positive integer. The remainder only 4. The remainder only 4. Here next to apply the operator, here 10 to the power of 1, here 4 remainder, next 4 remainder, next 4 remainder, up to 90 times, up to 90 times. Next to calculate sum of these terms. A sum of these terms is equal to 90 into 4, 90 into 4, 360. But 360, 0 is not correct, 0 is called unit digit. But this concept is called remainder property, remainder concept. A sum is equal to 360. A 360 is more than 6. That means again divisible by 6. A 360 divisible by 6, consider only remainder. Remainder 0, option A only correct. But not consider unit digit. But here 0, this problem 0 is okay, but not other problems. Suppose sum is equal to 345. In 345, 5 is not a remainder. If you want a remainder, it is a divisible by given number. Calculate only remainder. That is only answer of the given problem, but not unit digit. The sum 360, a 360 is more than 6, again divisible by 6. 360 divisible by 6, remainder is equal to 0. Therefore, 10 to the power of 1 plus 10 to the power of 2 plus 10 to the power of 3 and so on, 10 to the power of 90. Divisible by 6, that complete equation divisible by 6, that remainder is equal to 0. But in general, 10 to the power of 1 by 6, 10 to the power of 2 by 6, 10 to the power of 3 by 6 and so on 10 to the power of 90 by 6. That is the original method of remainder concept. Here next to apply the operator addition, subtraction, multiplication, division. Find the remainder only. Is this remainder 0, option A only correct. This is called equation model. Okay? Right. Next, seventh. Seventh important, using factorial. Factorial, remainder concept, but factorial concept already completed. Here factorial means 1 factorial 1, 0 factorial 0, n factorial n into n minus 1 into n minus 2 into and so on 3 into 2 into 1. Here first to calculate individual remainder, next to apply the operator. This question is belongs to equation model. These models only important to competitive exams. Here seventh example method. First calculate individual answer. 1 factorial divisible by 5. 1 factorial is equal to 1. 1 by 5. 1 by 5 remainder 1 but not equal to 0. 1 is not divisible by 5 and also don't convert into decimal. Next 2 factorial by 5. A 2 factorial is equal to 2. A 2 by 5, a 2 by 5, remainder only 2. Next 3 factorial divisible by 5. A 3 factorial, 3 into 2 into 1, 6. A 6 by 5, 6 by 5, remainder only 1. Now 6 by 5, remainder only 1. Here next 4 factorial. Here 4 factorial divisible by 5. 4 factorial means 24. 24 divisible by 5. Remainder only 4. Remainder only 4. Next 5 factorial divisible by 5. Here 5 factorial means 120. 120 by 5 exactly divisible, remainder 0. Next similarly 6 factorial divisible by 5. 720 divisible by 5. Remainder is equal to 0. And so on. 100 factorial divisible by 5. Remainder is equal to 0. Remainder is equal to 0. Once again, once more than 4 factorial, all these numbers, n factorial divisible by 5, remainder 0 when n is greater than 4. N is greater than 4. The 5 factorial, 6 factorial, 7 factorial, 8 factorial, up to 100 factorial. That remainder always 0. You consider only up to 4 factorial only. Here 1 factorial by 5, 1 remainder. 2 factorial by 5, remainder 2, 3 factorial by 5, remainder 1, next 4 factorial by 5, remainder 4. Here remaining 0 and 0 up to 0, up to 100 factorial, remainder 0. Next to apply the operator addition. Here 1 plus 2, 3 plus 4, 4 plus 4, 8. This sum 8. Again divisible by 5. Here 5 into 1, 5. Remainder only 3. 3 means option B only correct. Yes, easy method. Here competitive exams, these models only very important because logical method, but up to 100 factorial using calculator also impossible to calculate this sum, but a calculator exists only maximum 15 digits, more than that. But this type of questions are given applicable only logic but not general procedure. A logic short method 5 factorial, 6 factorial up to n factorial, that all these numbers remainder always 0. They consider only up to 4 factorial. Here up to 4 factorial calculate remainder individually. 1 factorial remainder 1, 2 factorial remainder 2, 3 factorial remainder 1, 4 factorial remainder 4. Next to apply the operator addition, that sum only 8. 8 divisible by 5, remainder only 3. Here remainder should be less than the divisor, but 8 is not correct, but that option also given. Here option D also given, but option D is not the correct answer. But remainder always less than the divisor, again divisible by 5, remainder only 3, option B only correct. This is about 7th example. This is about 7th example. Here next 8th example. Find the remainder on dividing 125 factorial by 10 to the power of 21. Option A 0, option B 1, option C 2, option D 5. Here this is called 125 factorial whole to the power of 10 to the power of 21. Here first numerator find number of tens. 125 factorial contains number of tens. Here calculate number of tens in 125 factorial. 10 is called composite number. Composite number convert into a prime factors. A 10 factorial is equal to 2 into 5. But number of 2's is more than 5. Consider only largest prime number. A largest prime number 5, that is 125 divisible by 5. Here 125 and 5 into 25, remainder 0. Next 5 into 5, remainder 0. Next 5 into 1, remainder 0. Here consider only sum of the quotient but not remainder. Same as number of zeros concept. Here applicable only number of zeros concept. That is first topic in number system. Here calculate total number of 5's. Total number of 5's 25 plus 5 plus 1 is equal to 31. Therefore, 125 factorial contains a number of tens 31. A numerator 125 factorial contains number of tens 31 divisible by 10 to the power of 21. And into something number, 10 to the power of 21 into something number, that is called 125 factorial. Here next to 10 to the power of 31 is also written as a 10 to the power of 21 into 10 to the power of 10 into something number divisible by 10 to the power of 21. Here next 10 to the power of 21, 10 to the power of 21 exactly divisible. 0 remainder. 0 into something, 0, then answer option A only correct. This is about 8th example solution. Important, again important example for competitive exams. Your method easy, but here applicable only number of zeros concept by using factorial. The topic is belongs to number system. First subtopic. First calculate 125 factorial contains number of tens. A 10 is a composite number, but directly divisible by 10 is not correct. 10 multiples 2 and 5. A number of 2's is more than number of 5's. Consider only largest prime number only 5. Therefore, 125 divisible by 5. Each case is divisible by 5. Consider only quotient but not remainder. A next sum of the quotient means number of 5s or number of 10s. A number of 5s 31, number of 10s 31. The 125 factorial is equal to 10 to the power of 21 into something number. Here 10 to the power of 31 into something number. 10 to the power of 31 also written as 10 to the power of 10 into 10 to the power of 21 into something number. It denominated 10 to the power of 21. 10 to the power of 21 divisible by 10 to the power of 21. That is exactly divisible. There is no remainder. Remainder 0. Here next to apply the operator. Here operator multiplication 0 into something 0. Therefore remainder 0. Therefore answer is option A only correct. This is about a remainder concept. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.